Alright, in this video what we'll be looking at is calculating the area of some special quadrilaterals, in particular parallelogram, trapezium, kite and a rhombus. So what we're going to do is we're going to start by calculating the area of a parallelogram. Now remember, a parallelogram is a quadrilateral with two pairs of opposite parallel sides. What we've seen previously is that the area formula for a parallelogram is the length of the base multiplied by the perpendicular height. Now in this case, the base length of the parallelogram is 23.04 and the perpendicular height is 8.71. So it's simply a matter of multiplying those two together, 23.04 multiplied by 8.71, which gives us an answer of 200.6784. So 200.6784 square units, and we'll round that off to one decimal place, so our area will be 200.7 units square. So in summary, we'll just put therefore the area is 200.7 square units. Next up we have a trapezium, and if you remember, the area of a trapezium is given by half of the perpendicular height multiplied by the sum of the length of the top plus the length of the bottom, and the pronumerals we use for the top and the bottom are our A and our B. So in this case we can see that the perpendicular height of the trapezium is 6.8, so it's going to be a half multiplied by 6.8 multiplied by the sum of the top, which is 8.7, and the bottom, which is 19.6. So 8.7 plus 19.6. Then we'll get our calculator out and we'll see what that comes to, which comes to 96.22 square centimeters. So, and we'll round that off to one decimal place again. So we've got therefore the area equals 96.2 square centimeters. Okay, next up we'll have a rhombus and a kite to calculate the area of. Alright, here we are. Over on the left hand side we have a rhombus, and we're given the dimensions of the diagonals of the rhombus, and on the right hand side we have a kite, and again we're given the dimensions of the kite's diagonals. For a kite and a rhombus, you will recall that the area formula that we had previously worked out was a half of the product of the diagonals, and the pronumerals we used for the diagonals were x and y, and that's because for a rhombus and a kite the area was half of the rectangle that enclosed the kite, or the rhombus in this case. So for a rhombus the area is simply going to be a half of 5.19 multiplied by 14.3, and our calculator tells us that that is 37.1085, and rounding to one decimal place, therefore our area of the rhombus is 37.1 square centimeters. Likewise for our kite, the area will be half the product of the diagonals, which is a half by our 8.04 by 9.75. 8.04 by 9.75, which is 39.195. 39.195, which will round off to 39.2 square centimeters, correct to one decimal place, and therefore our area is that. And now, just in summary to finish up, we've applied the formula for the area of a parallelogram, and remember, area of a parallelogram is given by the base multiplied by the perpendicular height. The area for the trapezium was half of the perpendicular height multiplied by the sum of the top and the bottom, which are the sum of the two parallel sides in the trapezium, and both the kite and the rhombus had the same formula. The area of those was given by half of the product of the diagonals. Anyway, that's all we've got in this video. We've seen a couple of examples of how to calculate the area of some special quadrilaterals. Thanks very much for watching, and I hope that was helpful.